Hey, what's up guys, welcome back to my YouTube channel, and in today's tutorial we are going to take a look at Perceptron. So Perceptron is a first generation neuron that was created, and today we are going to look at how it works. So before we take a look at how Perceptron works, let us take a look at how a natural neuron works. So this over here is a diagram of a neuron. And since I'm not a biology student, I might make some mistake while talking about neuron. So don't take this as your guide to knowing how a neuron works. I'm just going over the neuron, the parts that are needed for us to know how a perceptron works. So this is a tutorial on perceptron and not on a neuron. So with that cleared out, let's get started. Okay, so the first thing relevant to us about the neuron is called a dendrite. So this is a dendrite, and this is the place from which the information enters your neurons. And second is this part. So this is known as the cell body, and this is where all the calculations will take place, and after the calculations are done, it will pass on to the next part. So this part over here is known as an axon. So this was dendrite. This part is the cell body, where all the calculations take place, and this is the axon. And next is this. So these are called axon terminals, and this is the place from which your neuron sends some information to some other neuron or some other part of the body. So this is the place from which we get our output from a neuron. Okay, so now that we know the important parts of a neuron, let's take a look at how it works. So the information enters from the dendrite and it moves to the cell body. And this is the place where most of the calculations take place. So your neuron will perform some kind of calculations, and after the calculations are done, then your neuron will decide out of two actions. The first one is called activation, and the second one is called inhibition. So if the cell activates, it will send the information to the next neuron, and if it inhibits the action, so it will stop the information from moving to the next neuron. So it's kind of like activating and deactivating your cell. So during activation, your cell becomes active and it sends the information, and during inhibition, it stops the information from moving further because it decides that information is not relevant. So once the cell has decided what action to take, it passes that information on to the axon, and from the axon terminals, which is this part, the information travels to the next neuron. So this was the basic overview of how a neuron works, and now we are going to make a artificial neuron using this diagram. So let's get started. Okay, so the first thing that we need for a neuron is a input. So let's say these are our inputs, and all our information will enter through over here. And the second thing we need is a cell body. Okay, so let's say this is my cell body, and my input goes from the input to the cell body, and over here my neuron will perform some kind of operations. Well, it will perform two operations. First one is called a summation, and the second one is called a threshold function. So what will happen in summation is it will add all the inputs, and then after the input has been added, it will decide based on the threshold function what to do next. So once it has decided, it will pass out the information and give us a output. So this is a output. Okay, so this is the basic structure of a neuron or artificial neuron that we are going to be working with. And this was the very first neuron that was ever created, and this was known as McCulloch and Pitt's neuron. Okay, so now I'm going to draw a perceptron and tell you what were the changes that were made inside a perceptron. So let me erase this. Okay, so let's start building our model. So first I'm going to draw a circle. Okay, so this circle represents my neuron, and inside my neuron two things will happen. The first one is that it will add all the inputs that it is receiving. So it will add all those inputs and then it will pass the value to my function called f of x, and this is a threshold function and it will decide what to do with that value and then later on give us a output. Okay, so now let's move on to the inputs. Well, let's say that these lines are the inputs and this is I1, I2 and IN. Okay, so these inputs have some weights. So I'm going to say W1, W2, W3. Okay, so this is what a basic McCulloch and Pitt's neuron looks like. And in this model, our weights can have only two values. It can either be equal to +1 or it can be equal to -1. So the weight that has a value that is equal to +1 is called a excitatory weight, and the one that has a value equal to -1 is called a inhibitory weight. So this one. Okay, so now let's move on to a perceptron model. So this model had some shortcomings, so a better version of this model was created, and the difference between this one and the perceptron model is that the perceptron model first of all has a bias value. So the bias value basically controls your inputs. It allows you to control your neuron. And the second change that was made in perceptron is that the weights are no longer just plus and -1. Okay, so in the perceptron model, your weight can have any value. For example, in the McCulloch-Pitts neuron, it only had plus and -1. Now you can have +1, -1, 0, 0.5 and so on. Okay, so in perceptron you have some bias value that controls your model, and then you have some inputs, and those inputs have some variable weights, and these weights can have any value, not just plus and -1. So what you do is you first multiply these weights and inputs together, and then you add all these values. So after adding these values, you will get some value, suppose a, and this a is passed on to the function f of x. So I will pass a over here, and after passing it through the function, it will give me some kind of a output. So this is the basic functionality of a perceptron, and the only thing that will vary in this model is the function. So your function will be different depending upon the problem that you are trying to solve. Okay, so let me erase all this now. Okay, so let's take a look at how our model will learn. So the first thing is that we need some input. So let's suppose our input I is a set of inputs, that is I1, I2, I3 and up to so on, IN. And then we have some weights related to each of these inputs. So W1, W2, W3 and up to so on, Wn. And what you do is you multiply all these values together. So I1 will be multiplied with W1 and I2 with W2 and so on. And these weight values will be randomly chosen at the starting of your algorithm. So the next thing is a bias value, and the bias value will also be selected randomly. So let's say bias is equals to x. And then we have our learning rate, that is eta. So the eta is represented by this symbol, and this is our learning rate, and this will decide how much fast our algorithm will learn a certain problem, and we will get to it later on, but for now just know that we are going to keep it to 0.5, and later we will take a look at how and why we would want to change this value. Okay, so then we have some target outputs. So let's suppose that output is equals to A. So for this set of values, you will have a target output called A, and you will have more than one set of inputs, but your weights will remain the same. And while training our model, we will work on these weights and bias. So we will change the values of weights and bias values, and that way we will teach our neuron a solution to a certain problem. Okay, so now that we know all the variables that are involved in a perceptron, so let's take a look at how we can change the weights and the bias. So to change bias, first we need to know what is the error. So error E is going to be equal to the target value minus the obtained output. So the target value is the target output, that is A, and the obtained output is going to be a value that we obtained from the neural network. So now that we know what error is, let's take a look at how we can modify our weights. So let's say weight new is equals to the value of the older weight, so WO, plus the learning rate, that is eta, times the error times the input that is related to that weight. Okay, so this is the equation that will be used to modify our weights. And now let's take a look at the equation that is used to modify our bias. So I'm going to say B new is equals to B old plus eta times the error. Okay, so you can use this equation to modify your bias values. Okay, so now let's apply everything that we have learned up till now. So what we are going to do is we are going to teach our perceptron to learn a AND gate. So to do that, first I'm going to erase all this. So this is what a AND gate would look like. So this is my first input and this is my second input. So 0 0 and the output will be 0. 0 1, the output will be 0. For 1 0, the output will again be 0, and for 1 1, the output will be 1. Okay, so we are going to teach our perceptron this AND gate. Okay, so let's get started. So the first input is 0 and 0. So let's say I1 and I2 is equals to 0 and 0. So the first thing that we need to do is we need to add these values and multiply them with the weights. But we haven't decided what our weights will be yet. So when we move on to programming this problem, we will generate some random weights. So for now, I'm going to set the weights equal to 0. So W1 and W2 are going to be equal to 0. And then the bias value is also going to be equal to 0. Okay, so next we need to add those two values after multiplying them with their weights. So 0 times 0 plus 0 times 0 plus the bias value, that is equals to 0, and it will give me 0. So my summation is equal to 0. Next we need to pass it into some kind of a threshold function. So we haven't decided what our threshold function will be, so let's do that right now. So the threshold function will be equal to f of x, which is equals to 1 if the value of x is greater than or equal to 0, and 0 if the value of x is less than 0. Okay, so this is going to be our threshold function. Okay, so now that we know what our threshold function is, let's pass our summation into the function. So if I pass 0 into my function, it will return me 1. So my value is equals to 1. So next we need to check the error. So error is equals to the target minus the output. So my output is this and my target is this for these two values. Okay, so 0 minus 1 is equals to minus 1. Okay, so now depending upon the value of the error, we will either update our weights or we will not update our weights. So since my error is not equal to 0, I will update them. So every time you get a error that is not equal to 0, you need to update your weights and bias values. So W1, W2 and W3. Okay, so to update our weights, so let me write down the equation that is needed to update our weights. So to update weights, we need to get the old weight plus the eta times my error times my input. And to update bias, I need the old bias value plus the eta times the error. Okay, so let's try to do it right now. So my old weight is equals to 0 and value of eta, well, I told you that eta is going to be equal to 0.5. So I'm going to take eta is equals to 0.5 times my error, that is minus 1, times my input value, that is 0. So if I solve this, I get the value equal to 0. So this was the value for the weight W1. So my W1 is now equal to 0. And for W2, the older value for W2 is equals to 0. Eta is equals to 0.5, error is equals to minus 1, and the input value is equals to 0. So it will give me the same value, that is 0. And now let's modify our bias value. So the old value for bias is equals to 0 plus the eta, that is 0.5, times my error, that is minus 1. So now the new value of my bias is equals to 0.5. So minus 0.5. Okay, so let's move on to the second input, that is 0, 1. Now I need to perform summation. So I'm going to say 0 times W1, that is 0, plus 1 times W2, that is also equals to 0, plus my bias value. So my bias value is equals to minus 0.5. Okay, so now if I solve this equation, it will give me minus 0.5. So the summation is equals to minus 0.5. Now if I pass it to my function, since it is less than 0, as I stated over here, then my value will be equal to 0. So my function will return 0 and the expected output should be 0, or the target value is 0, and my actual output is also equals to 0, or my obtained output is also equals to 0. So the error is going to be target, that is 0, minus the output, that is also equals to 0. So my error will be equal to 0. Now since I have 0 error, I don't need to update my weights. This is bias, sorry. Okay, so now I'm going to do the same thing for these two inputs. So I'm going to fast forward this part, and I hope that you do this on your own. So you can pause the video if you want to perform these two calculations on your own. So I'm going to fast forward it right now. Okay, so after doing all these calculations, I had some error over here in this input, and so my error was 1, so I updated my values for the weights and the bias. Okay, so now that we have exhausted all our inputs, what we need to do is we need to perform all these operations again from the starting. So we are going to take this input first, then this one, and then this one, and then this one. And we will continue this circle until we obtain all these actual values that we want from all these inputs. This is known as a epoch. So since you exhausted all your inputs and there are no inputs to cover, so this is your first epoch. So epoch 1. So try to remember this term, and every time I talk about epochs, just remember that epochs are basically the iteration over an entire set of inputs. So if I have covered all these inputs, then that would make it a single epoch. Okay, so now we are going to take inputs as 0 and 0, and then we are going to multiply them with our weights. So if I multiply 0 with 0.5, it will give me 0 plus again, so 0 times 0.5 plus 0 times 0.5 plus my bias value, that is equals to 0, and it will give me my result, that is equals to 0. So this is equals to 0, and my function will return me my value, that is equals to 1. So my actual value should be 0, so my error is -1, and now I need to update these weights. So the new value for the weight W1 is going to be equal to the old value, that is 0.5 plus eta, that is 0.5 times my error, that is -1, times the input. So this will return me 0.5, and W2 is going to be 0.5 plus 0.5, that is eta, times my error, that is -1, times my input, that is 0. Okay, so next I need to update my bias. So my bias value is 0 right now. So I'm going to say 0 plus 0.5 times my error. So this will return me -0.5. Okay, so the new values are 0.5, 0.5 and -0.5. Okay, so next what we want to do is we want to enter all these values again and again until we reach the desired outputs. Rest of the steps are pretty similar, and so I'm going to skip to the last step. Okay, so right now I am at my 5th epoch, and my values for weights are, so W1 is equals to 1, W2 is equals to 0.5, and the bias value is equals to -1.5. So I'm going to start the 6th epoch now, so 0 and 0. Now if I perform summation over here, so my weight values are 0 times 1 plus 0 times 0.5 plus -1.5, and this will give me -1.5. So fx is equals to so if I pass -1.5 to my function, it will return me 0, and my target value is also equals to 0, so the error is equals to 0, so I don't need to change my weights. So 1 0.5 and minus 1.5. So the next input is 0 and 1. So 0 and 1. So if I add these two inputs, so 0 times 1, that is W1, and 1 times 0.5, that is W2, plus minus 1.5. So if I solve this, it will give me minus 1. So if I pass it to my function will return the value 0. So that is my desired value. So the error is equals to 0, so no need to change my weights. Okay, so the next input is 1 and 0. So 1 and 0. So if I try to solve this, so 1 times 1 plus 0 times 0.5 plus minus 1.5, and this will return me minus 0.5. So if I pass it to my function will again return 0, and my expected output is equals to 0. So my error is also equals to 0, so no need to change my weights. So the next input is 1 and 1, but since we didn't change our weights, I already know what it's going to be. So 1 and 1 will give me 0, and my function will then return 1, and my error is equals to 0, and my weights remain the same. Okay, so this is how a perceptron works, and now as you can see, my perceptron has learned all these inputs, and if you pass any input inside there that is 0 or 1, it will give you the accurate output. And if you want the solution to this problem, it will be in the description below, and in the next tutorial we will be coding this into Python using NumPy. If you have any questions, leave them in the comments below. If you thought this video was helpful, you can like and subscribe, and if you want to be notified every time I drop a new video, you can turn on the notifications. And I'll see you in the next tutorial.